Hi there. A little while back, I did a video on tuples, and in that video, I made the statement that a nice way to pass values between functions is to use a struct. And then later in the video, I started talking about tuples being mutable structs. So some of you caught on to this and wrote to me and were like, hey, so what's a struct? Isn't that a class? And I realized that we have a teachable moment here because the difference between structs and classes is a subtle and really important thing to understand in C#. So here you go, structs versus classes. So the key difference between a class and a struct is that a class is a reference type and a struct is a value type. So let's look at some code to understand what that means. I've got a function here called doSomething, which takes an integer and a Boolean. Now, int and bool are C# primitives, and they are both value types. And what that means is that these are private variables, private to this function, and it has its own copies of them. Anything it does to them remains local or private to this function. So what you can see is I'm incrementing I by 10, I'm twiddling b to not b, and then I'm writing out those modified values. In my program, I have some test code. I initialize another variable I to 5 and a Boolean b to false. And then I call my doSomething function. And then again, I write out what main thinks I and b are. So let's run this and see what happens. Notice that doSomething, its copy of I has been incremented up to 15 and b has been twiddled to true. Main, its copies are unchanged. So that shows you what a value type is. It's passed as a copy. It's passed a copy of the actual value. So let's contrast that to a class, which is a reference type. I've got a class here, which has a Boolean and an integer. And let's write a function similar to this one that uses the class. Public static void doSomethingElse, which takes an instance of our class. And within the function body, we can say c.number plus equals 10 and c.flag equals not c.flag. And we can write out a similar console message. We'll have to modify it. So we'll say that number equals c.number and flag equals c.flag. And then let's write some test code that exercises that. So over here, we can create a copy of our class. And we can initialize its properties, the same as the other. And then we'll call class versus struct doSomethingElse, passing in our class. And to save a little typing, I'm going to copy this, paste it here. And now main is going to say what it thinks number and flag are. Can you imagine what will happen? Let's run this and see if you're right. So doSomethingElse reports that number is 15 and flag is true. And main also says that number is 15 and flag is true. So why is that? It's because we have one instance of class. There's only one of them. And when we call doSomethingElse passing in C, we're not passing a copy of it. We're passing a reference, a function pointer, or a memory pointer. It's pointing to some heap allocated memory where that object is stored. So there's just one instance of the object. And when this function doSomethingElse modifies it, it's modifying that same copy. So everybody sees the changes. So that's how a reference type works. Classes are reference types. So what about a struct? Let's go ahead and copy the class, and we'll define it as a struct, and we can name it struct. And now let's copy our function here, and we'll call this one doSomething with a struct. And we want to pass in a struct, and we can name that variable s for clarity. So we'll do the same kind of code here. So we'll just change the message a little for clarity. So there's our function that does pretty much the same thing, but with a struct. And we can write identical test code. We're going to do something with a struct, passing in s, and we'll change this to say the struct number is s, and there we go. Okay, so what is going to happen? What do you think? Let's run it. So do something else has incremented the number and the flag and changed the flag, but main's copy is unchanged. So what you can see is that the struct behaves exactly like the separate int and bool variables. So really a struct is just a package of data that gets passed, and when you pass it, you get a copy of it. Now, in the last video, I talked about mutable structs, and that's what we have here. This is a mutable struct, meaning we can change it, and you can see the code right here that changes it. Now, there's an argument, a pretty strong argument, that says you should not allow your structs to be mutable. They should not be changeable. And the reason is that I think you can probably imagine that if you wrote code like this, somebody who doesn't really understand exactly what's going on might think that it really is behaving like this. And they would expect that this struct s has been changed when it hasn't. And that can create some subtle bugs. They are not compiler bugs, they're runtime bugs. And it can create some unexpected behavior. So that's the motivation for the idea that structs should be immutable. So you can make your structs immutable, you can make them not changeable by marking them as read-only. You have to spell it right. Now the compiler is complaining because if you mark it as read-only, you're saying all of the members should also be read-only. So one way we could do this is to make these properties that have only get accessors. And I also want to create an init accessor so my little object initializer will work. So now these values are not changeable. And down here, the compiler is complaining correctly that you can't do this. If I want to change struct, I have to make a copy of it and be explicit about the fact that I'm making a new one. So I'm just going to remove those lines of code. Because I have this init keyword there, this line still works. I'm still able to set those properties in an object initializer. And now our code should still work. We didn't change anything in terms of how it compiles. The behavior is a little different. So that is my recommendation. I recommend that you do use structs for passing data. It's a very efficient way to do it. And I also recommend that you take the time to mark them as read-only. And if you're finding that you really wish you could be modifying your structs, you probably should be using a class. So there you go, struct versus class.